Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Today we are on an adventure to continue uh, processing, making this transformation for the debug tracer, where we are trying to implement hardcore reloading for trace target for the target process, as well as in the same way as we did to the uh, EagleFly platform independent render and processing stuff. So uh, we are just about making that change. Uh, it's pretty much it works pretty much the same way, just has some little difference, of course. But yeah, we'll see. We are kind of exploring the things. We have to see how it goes, and we will see. Okay. So if you would like to follow and watch how we make whole core reloading for the target process inside our debugger, please welcome. And if you have any questions, you can post them on Twitch, Twitter, or YouTube, and I'll be there to answer them. With that in mind, I would like to open the project that's already open, and I'd like to compile. And there you go. We have an error, and that's the error that I want to see, because if we remember, this is the place where we left off, that we have to make this audio. And now, I mean, this is like something really good to consider, because I was like thinking throughout these days about, well, how can we make all this work in the whole sense. I mean, we know what each part has to do. We just have to we've been like trying to set in these little pieces one by one, so that we can see the whole picture and see what's going on around the whole process. And I mean, right now we have a question that we should answer, and is that we know that we have a parser. Let me go to the parser, and this is a PDB parser that basically loads the whole set of symbols that a PDB has, and all those symbols are the ones that get collected from compilation process, where the linker and object files, basically the linker dumps all this data into here, just about the way that it does for the image file itself, so that we have a kind of cousin of an image file, but it's not an image file, of course, in any sense. But it has the data pretty much of the whole build process. Probably not the whole, but of the build process. And we have like build flags, compilation flags, link flags, compiling data. So I mean, I think I already said that, but we have a bunch of stuff there. And yeah, I mean, that's pretty good, that's useful, but we don't want the format that they have. It kind of sucks, and we already have we have many reasons why not to follow that route of using the same PDB format. And one of the reasons, of course, is that we want to have some kind of independence across the debug information format that EagleFly debugger wants to work with, such as if I go to the info, we've defined all these structural data that basically it's gonna work as the main working data format for EagleFly. And the reasons why it should be better to have this instead of having a dependency onto the format of PDB format is that you can have in one case you can get independence, and it will be in the future probably it will be easier for us to port. I mean, if we want to get rid of PDB files at all, and instead of parsing PDBs, we want to parse it, all the data out ourselves. We can do that because we have defined a spec for the data format that we want to trace, for data format that we want to get from a file or from the target process. That's one reason. And another reason can be because it simplifies the search stuff. It's super well. It defines a way that the debugger itself can work. And it's we can define our own stuff. We can define extra stuff that probably the PDB itself doesn't have or doesn't handle, and have some kind of data structures that the PDB itself doesn't have that we can construct ourselves as needed. So yeah. So with that said, the thing that we could do that I've been thinking through is like, well, we want the PDB parser, or at least for now, to be like a let's call it like a working thread. I want the parser to be like a working thread, so that every time we need to gather that data, we can tell the let's say this process or the PDB parser to basically gather and collect all that data for us, and to build it on to we'll say to a file, could be, so it's gonna dump all this data to a file that we expect with these things, so that in any moment we need to grab something from the file that we expect, we can do it ourselves, and we don't have to deal with the PDB directly. So I think that's nice. Also, another thought about the working thread is that if you see here on the EagleFly tracer, we basically have divided itself to have these two calls with load image and unload image, so that we can basically load the process that's working on and load and unload it every time we want. And here we have this we try to load debug info from PDB, and this is a code that we are kind of intuition, or we're kind of like looking forwards to be a call from the parser itself, so that we can call into it, some kind of callback or something. And well, that's the idea, that's the first thing, like, hey, have a DLL that we can call and just get the data process. And that's like that can be a good thing. But remember, we have a caveat here that let's say we have since we removed this from a working thread, as you remember, not WinFree to load image, but the tracer itself is now in line into the Win32 platform, it doesn't anymore do we don't have this parallelism or this working thread that we so that we can like continue rendering stuff and stuff like that. So that's a caveat that we have, and we probably now that we say working thread, we can basically and do some kind of that work. I mean, retake our repurpose that working thread so that now the whole point of the working thread is to manage and do this whole stuff, you know. That can be a reasonable thing to do, you know. It's not something totally weird in any sense. And probably, yeah, I mean, it's a kind of idea, but I mean, we have been like constructing the necessary blocks of what should be separated from what. I mean, what data it's independent of other data, and as it goes, we think we could I put here make this working thread, and the reason we can, of course, we need to, this needs to wait for the PDB exists for this image to come back, so it would be some kind of wait, some kind of wait for symbol, so that it can start to process the data, you know. That can be a way. If we don't do the working thread, the only thing that will happen, of course, is that we will not be rendering until all the data came back, you know, and we make sure that it was possible to do all that stuff, you know. So yeah, I mean, it's it's not like the end of the world if we don't have that, but it's some kind of nice thing to have. And yeah, so probably we first are gonna define our, let's say, for now it doesn't matter. We're gonna focus now on the deload part, so we can see what comes out of it, you know. And it's gonna define some kind of a useful information that we can export or something, you know. So I want to say something like this, and I believe we have something in Win32.h that we define itself as to be some kind of useful. So we have debug date render and debug date tracer is now gonna be not this but it's gonna be I'm gonna call it different. Load and I'm gonna define this on the platform itself. Here's the thing that we define. We can change this to and we define it here on the tracer to be something like we want to pass the dispatcher state. We want to pass Now, there's one thing to consider is that imagine that we're gonna get the file, and we're gonna load that. Um, I don't know. I mean, the only thing that I'm considering now is like whether we have to. I mean, like the parser itself is gonna dump the data to a file, and then we're gonna parse that file to get that data out. So we have to like kind of to have like this like process of doing all this stuff. That can be one way to do it, or rather just instead of doing twice, we will get the whole stack. And it depends. We have some caveats there because probably, I mean, we don't want to have the whole file since the PDB can be large. That's an important thing to consider. The PDB can be huge. It can be. I mean, we don't know. I mean, you don't know Visual Studio, or, sorry, MSVC, and you don't know MSDN, and probably you can do bananas with the file. So it can be huge, and also because the project itself that we are the target project that we are expecting to debug with this debugger, of course, has to be has to have the capacity to handle such huge kind of sizes, So that's something really important to consider. So we don't want to have the whole file in memory, Of course, we have to do some kind of virtual memory system that probably allows us to map in and map data out, in and out all the time, so that we can play around with that. So yeah. So I mean, it's not. I mean, this if this is the file that we are looking, that it's an imaginary file because we don't have it. We don't have it right now. It's something that this, well, not this, but the parser itself is gonna dump, and we're gonna get it from there. So probably. I mean, it's not totally necessary to have the DLO specifically for this call. It's just the loading and unloading of the data itself that we have to finish. So yeah, it's kind of tricky. It's kind of tricky. So I think we're gonna do the simple stuff. We're not gonna care since we don't know pretty much right now how this define is gonna look. We're just gonna define. I mean, it's not gonna be any dealer or any fancy stuff. We're gonna just define more usage cases. Probably I think that's the best thing to do. And we're gonna just define to construct more. Let's say, I mean, we're gonna look at in this way. And for now, we're gonna keep it that way. And this is gonna be we don't care. It's good not to have too many DLLs. But yeah, I mean, we will see later what we need and what's gonna happen. So for now, I would like to continue with the parsing stuff so that we can define it. We have already a load thing. So the first thing I would like to do is I'm gonna go to the tracer, and for now I would like to see some kind of scoping stuff working on, like I wanna have the capacity to display the data, all the symbols, all the data semantically, so probably we want something more like let's say right now we have this like a line map from address and display line symbols. And this is, I mean, this pretty much works just for getting up some line in the address space and then display the line symbols for that specific line. So this is I was thinking the last day that probably this has a caveat, and the caveat is that, I mean, in assembly itself we have jumps, and even though normally, I mean, we see normally in assembly like let me open this up. Let me if this let me see if this runs, compiles, so I can show you the assembly. I don't know, I'm just gonna run the first stuff so we can see it. There you go. And I wanna go to the assembly, disassembly, I guess, to the disassembly. Yeah, because assembly, it's the binary, which is not too far from this, but this is getting to the opposite way, from the binary to opcode instructions. So I mean, this is the opcode, and normally, I mean, it's pretty straightforward because it's all in line, and there are pretty less jumps, but it can be jumps, and the user itself can have any jumps defined that, for example, I don't know, I mean, some instructions, I mean, it's not hard to say that, I mean, there's not like really let's say a direct mapping from line expressions to a block of code instructions. That's what I want to say, and that's a tricky problem, because if we don't have that, then we will need to have a better representation of it, so we can gather that data, and if in someday we want to have this mapper from this like this. For example, we have Visual Studio has this mapper from assembly and and the and the source code, so we always know that, hey, we are in this line and we are in this address, and we can move from address and the line is not gonna change. Not change, not change, not change, not change. And then it's gonna, I think, let me see the opcode here so we can see where it's supposed to change. It's a move. This is a call. This is load explicit address. And this is I don't see the stack pointer. Where is it? Oh well, this is the code to win to get exe path. It already returned from it, so the stack is already gone on this moment. And now we have also another call here that's win to another get exe path. And we have the same. Okay, so I think yeah, we have here the other get exe path. So we're basically doing the same stuff here. So we're still there. And there you go, we execute that instruction, and now this is the first instruction that maps this. So that this makes me think that we could like have a like direct mapper from opcode or from instruction address to a line. This line block or this instruction address block maps to a certain address, and that's basically what we have right here right now. That's the probably the most visible thing that we have right now for the format that we expressly define that we want to have. And I mean, it's not that bad. I mean, most of the time we have that kind of blocky thing, which is nice, I guess. So, but I mean, nothing assures us that it will always be the same. If somebody wants to write its own assembly and it's gonna do a lot of jumps between blocks, probably it's gonna get to another block of data and another block of instructions. It's like jump to this segment now and with its offset or anything. So now we have to I mean probably I mean it's not, but now that I think about it, there will be, I mean, we jump from one code segment to another code segment. Imagine that it's in the same well, one thing that we don't know is, I mean, how does the code segments get laid out in the image file itself? Because and I think that's something that it's inside the modules themselves. We have the segment descriptors and stuff like that define a lot of information there that we can take a look into. So that we have, for example, is not this, no, is this one.
So just for starters, I mean, without thinking too much, we'll assume that we can have like that, like code block thing, you know. I don't think it's gonna. If we see that it's not the case, and we have to make some kind of structural changes, well, we'll do it. Doesn't matter. So it's on the info thing. And I would like to have I don't know, probably like bum 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 da, 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 da. Probably I don't know, I have to what. Okay, so yeah, probably something like uh
For example, where is it? Dart tracer. I would like to display the whole stack. Well, I mean not the whole stack, but the current stack, for example. So we know that this is the stack and this is the variables locals to it, you know. And I mean I don't know what. I mean it's pretty normal to have that. I mean I was just like thinking, well, uh, it's not like such pretty useful to have like local scopes. I mean, in the sense of, I mean, we know what a local scope means and stuff, but I think it's more important like this watch window of of transient variable search information, you know, so that yeah, I mean you want to get this kind of I mean the source code itself tells you like the scope of it, you know, like oh this is how. Of course, I mean if you have like a list of all the variables that are in this scope, it's I think it's useful. Yeah, I mean it takes out all the garbage of extra code that it doesn't let you see so easily the whole set of variables that you are like kind of dealing with in this scope or something. But I think that's the only reason why to have this variable scope list. So I mean it's not too bad, you know. For example, another thing we can do here, of course we want to display line symbols. And I want to display local watch variables. So we have to have that cache. Display local symbols, watch symbols, I guess. I mean probably these local symbols is like instead of this one, I guess. I mean, well, line symbols probably mean like the source code itself, you know. You know, some kind of this thing happening. I mean, it's, on breakpoint stuff, it's gonna be like boom, like display me the whole scene. I want to see everything. I don't know what else. The registers and stuff. That's something like these thing. That's another Win32 display x64 registers. That's something. The source symbols line, the assembly symbol set line or something, you know. And that's also something important. Like, does the PDB has any assembly symbols? Probably not. Isn't well, probably yeah. Although we don't know. I mean, the thing that Visual Studio displays the disassembly doesn't mean that it gathers it from the PDB, but we should take a look, of course. We know that there's the source line symbols and stuff like that, but we haven't taken a look of where does the disassembly information comes from. And for example, one nice thing about having like this kind of mapper or address block line mapper is that it can have some kind of symbolic display for, I mean, from somebody that doesn't like really understands this assembly. You can look at the blocks and start like looking like, hey, you know, this is the thing that happens um, for this line of code, you know, and it's way much simpler to understand. Of course, I mean, it's not like well, yeah, I mean, that's cool. Well, I think we can start with this. I mean, it's not like the definitive thing, but it's just like some stuff think like, hey, we want to see this. I don't care how, but I want to see this, you know. So probably, yeah, we want to have a scope index. And I don't know if you want to have a tree of it, you know. uh, because since I mean, we just have like this serialized thing where there's no kind of uh, I mean, we don't know which symbols belong to which scope. We have just like scope index and stuff. I don't know if we want to have some kind of hierarchy there. It's tempting. So let's say, for example, we're gonna start working with, for example, this one, so that we can see the scoping thing at all. So if we go directly to the line map, and the tricky thing, and this is the funny part, is that we know, we cannot assume anything, because we cannot assume where does we are gonna stop, we cannot know that. The debugger have to handle everything from the breakpoint reference, so it has to construct the hierarchy based upon that set of data. It has to go from there outwards, and look at the whole symbol stuff working out from there. So probably that tells me that we have to have a way to manage that that kind of construction thing in a way that lets us easily to reconstruct the whole call stack, so yeah. So probably I want to have like, let me see. So let me think. Let's say we want to, okay, let's say I'm gonna write this in line so we can see it. So we have to display the whole source symbols at line, well, at line, and display source something like that. So this is where it comes tricky part. The symbol entry can be, if it's a plain, let's say it's a plain a plain table, so that each time we see one, I mean, we can just go going upwards in the table, and we would like start looking at these lexical scope blocks that like that define or that uh, compresses like yeah that scope the symbol itself. I think that should be some way. So I want to say something like this. Let's say we have a bunch of symbols. How do we know which symbol it maps to? We get it from the get line map from address. And this is the address line map that basically tells us the begin and end offset. And I was like thinking, well, what if we define the block itself to be a code block? It's gonna be. I mean, because if we remember, I mean, this is the tricky part. Like, which. I mean, assembly doesn't have any kind of hierarchical data. I'm sorry. I mean, he doesn't care. He doesn't care at all about hierarchical stuff. He's just like, hey, I want to execute this instruction now, and then jump to another instruction, and then jump to another instruction. So it's like going, he doesn't care about hierarchies. It doesn't exist, So like, hey, I'm moving this up to memory. I'm moving up this to memory. I'm creating a call stack. I'm removing these things from a call stack, and that's all. I mean, I like that because it's super simple, but of course, I mean, the lexical things about the language itself, it's like this kind of a like adds extra complexity to these to the data itself, so we can do something like this.
And what I'm gonna do is this. This is not gonna be line number anymore, neither this. I want this is gonna be this. It was a function, a thong. It can be an inline function, but it will be the same. Braces, and I'm gonna put here node Alex. This is C++ language dependent. But yeah, I mean, this debugger is totally C++. It's not gonna support any other language. At least, yeah. I mean, yeah. I mean, at the debugger it has this kind of truly dependency to the language, which is a little bit problematic, of course, but it doesn't matter. It doesn't matter. It's okay. So this is the C++ language dependency, func, thunk, brace, and I don't know what else was inside there. I think I can see here. We can look at I mean, and this is not really a stack, but it's just like a branching stuff. It normally, or it's a branch, or it's uh yeah, I mean, it's a function or it's a block. I would say block. And the thing I was like thinking that probably we want to have two ways of traversing the data. Mm, I mean, not the data, but I mean the different data, because it would be simpler for us to have C and C++ to be parsed as a lexical scope thing, and binary and stuff to be the way that we had it here, you know, like with these kind of blocky stuff, you know, like I mean the line number, it's probably, I mean, I prefer to look at a code block index, and this is this as some block. And this is like that, and I want to have a way to, we have a lexical scope type, so probably lexical scope. And this probably is going to be something like function data or
probably I wanna call this and the struct class is a special one, but probably it's something that could be here. Yeah, I think EagleFly it's better. Or EagleFly. There you go. So, and I wanna say something like this. Um, well, not exactly this, but more like I mean, and this is independent of the data itself. It's more like this is more like I want like a switch here to not necessarily a switch, but a series of views I probably want to see from the data itself, and at least we now have like and this is like the tricky thing. uh, it's like, well, I mean, normally, I mean, for example, Visual Studio has a lot of views, you know. I mean, if you think about it, it's like I don't know. I think it's not gonna. I'm not gonna look at anything here, but I mean, you got the idea. I mean, oh, we got it. Okay, so I mean, look at this. I mean, it's like, oh yeah, we have the source, we have the binary, we have the, and I think it's I mean, like trying to handle all these kind of views is kind of problematic. I mean, and I'm not saying that there's no reason. I mean, there's no good reason not to do it. I mean, I think it's useful to have, like, of course, some specific data layouts for different types of data, but uh, I think we can do something really good simplifying the views themselves, you know. Of course, we want some kind of mapper from code to DSASM, you know. I think that's, I mean, it's one of the most important things. And but we also have to take into account how to cohesion. That's the word. I want cohesion, because Visual Studio doesn't have pretty much a lot of cohesion. I mean, all this looks like if the data is like, hey, I mean, I don't know how to display it, and I'm just gonna put it there, and I don't care. You, it's your problem with how you want to understand the data, and that's it. And I think it's that's the problem. You know, I mean, they have these useful things, but I mean, there's no cohesion across different views. You know, it's like, well, you know, I mean, I see that every time I step into, I see transformations. You know, I mean, I see everything exchanging around and moving up, and that's good. I mean, that's kind of the whole thing of aspects of the part, but I'm not seeing like kind of a more how can I say, constructive display of it. And probably, I mean, it doesn't matter if it's not like totally clear how could that work, or how could we try to improve that kind of view information for a debug system. But at least for now, I just want to say something like, I just wanted to say hey, like, oh, I want to see this, and this, or at least have a way to do it, so we have some kind of flags like, hey, we are looking at this, or we're looking at that, or we're looking at this or that. I mean, probably, I mean, for starters, we're just gonna display everything, you know. I mean, we're not gonna have like these fancy closing stuff and stuff. So we're just gonna dump everything, like some kind of ordering, and later we're gonna start working on how do we want to display all that stuff, you know. So the fly mode, it was just more like where you see mode view flags. So yeah, I mean, I'm not gonna care too much about this. Probably it's gonna I wanna do something like that, but I wanna be moving across these two kind of, and this is kind of interesting, because I wanna be moving across two different data structures. Like, for example, if we say step into or step next, you know, and step next has to treat these two data layouts and start making transformations across that, you know.
So that's kind of interesting. So let's continue. So yeah, care too much about that. Probably I'm gonna put this like a to-do. And I wanna first say EagleFly and this is gonna be I don't know, we wanna have a root. I'm thinking on how do we want to match these two, you know, since we know that they're gonna be looking at not necessarily yeah, they're gonna have to be different symbols, but they have to match. let's say let's say that we have what if we match these two? you know, so that they refer to the same data. I mean, and the reason that I'm doing this is like so I can respect the thing that we were looking at, so that we have the begin offset and end offset and the segment index. Uh, I mean, respect the kind of this. I want to disambiguate the what these two mean to be, you know, and of course, I mean the lexical scope is gonna have its own data, so they can like I wanna traverse this stuff, but the DSASM, I mean they're gonna basically map to the same block of data. You know, it doesn't matter how it is. We're gonna just do the same range of stuff. So, for example, because I mean the reason that I was like looking through is that the most normal thing to happen in whenever we are looking into things is that we want to display everything in that stack frame, you know, so that we have to have the possibility to display the whole stuff. So I want to like have an easy way to access that data once I get to the point that I got to access. You know what I mean? So if I'm gonna like some kind of I want to say something like this, you know, like begin access to data. Begin access to data and you know I want to get to somewhere and I want to stay there so that every time we like set a breakpoint, and you know there's gonna be special cases when, for example, we step into the like say step next to that's like kind of is gonna probably stay in the same stack frame most of the time. It can jump, but you know I want to have some kind of easy way to access to a certain part of the data and stay there, and so that and that has some kind of relationship to the disassembly, the probably not the watches, but just I mean right now I'm just thinking about source code and disassembly itself, you know, so that we can match both of them, so that every time it would be trivial to have the source and the disassembly being displayed almost like if they were the same stuff, you know. You know what I mean? That's the thing I'm like kind of looking at. So probably it's like begin access to data, and I want to say something like access begin access to data, and I'm gonna pass the state and get debugging for this state, blah blah blah, memory index context rip.
want to, where is it, get live format, yeah, this thing. Basically I want this thing. Oh my god. Begin access to data. I want the and probably we can do this inside so that we start working inside. And the begin access to data is the one responsible to get us to the level we want and stay there, you know. So we have, oh my god, Jesus Christ. Yeah, it gets us to the state, gets us to the lexical scope, the disassembly scope, everything there, and some kind of and access data. And probably so I want a way to relate this to this. So probably we want to have some kind of struct I will call it and probably this is the one that's going to be in charge of this. I mean, I want something like this and something like this, and this is let's say yeah, because I mean you think this traverses the things like owned by itself, you know, like hey, I'm gonna get to the next one. I define a way to do it with this data. but this thing defines a way to get to both of them on a first on a specific, you know, a specific section, let's say. So if we want to get to a specific, let's say, part of the code, and now just think about it, the thing that we have first, it was good, you know, because always the first thing we got is the line map, is the address pointer, you know, is the ESP. So if you think about it, it's not too bad to have, I mean, it's not such necessary to have that, because we have a way to do it, so that the EagleFly disassembly code block basically is our mapper. It is the one that has the power to define which data and lexical scope we are looking into, you know. So we just have to like organize this in a way that we say clearer that these two are like the way that they are related, you know. And this is so I think I like this. I'm gonna just do this, and this is gonna be here, and this is gonna work in a way that we can start looking at the disassembly. The disassembly is the one in charge of telling me, oh, this is the offset I'm looking at. Probably it's gonna have the whole list of symbols themselves, and it's gonna have the EagleFly lexical scope that defines the symbols, you know. EagleFly symbol entry. Now of course there's more symbols than that, you know, lexical. me see. I think
uh yeah, so the first thing that we were doing probably is good. So probably it's more like this, more like begin access to data. I like it, it's good. mm, and probably let me put do here. Yeah, I mean there's like all this kind of uh different ways to look at it. Now the thing I was thinking that if we are gonna define it this way, now the blocks themselves have to have some way of I mean, if we are looking at a block, a lexical scope, we have to define those memory addresses to have like those same lexical scopes, you know. But uh, um, normally, well, I mean, yeah, there's no problem with that, but we'll have to mm, some extra data in there. But it seems like it does has this assembly. Let's see. It has a register type, but I don't think I don't know if that meant for that. So probably we want something like this. I probably construct. I mean, yeah. I mean, yeah, yeah. I like it. So I mean, we are seeing that. Hey, I mean, this thing is gonna do a bunch of stuff there. That's gonna. It's gonna try to construct the whole lexical scope in there. For module. Yeah, because probably it can cross across modules. Whenever yeah, we have a DLL, for example, it has to construct it back into the other modules. So it's not module specific. So if it's not module specific, probably we want some kind of So yeah, I think that that will work. Of course, I don't know if it's the best thing, but I think it's something that we can use now. It has lexical scope inside there, and we can construct the lexical scope. We have display source file align, display local symbols. I don't know, and probably this. I don't know. I don't know if we want to. But yeah, it's something like that. Something like that. And probably, I mean, this is not here per se. It's gonna be whenever we continue the execution. So probably it's something like here. And probably this is like save variables, watch variables, search what symbols. Now the thing, I mean the save. Yeah, we have to think more about the save thing a little bit more. It's not there specifically, but we have to uh, yeah, to deal with that in a certain manner, you know. But first, I want to see the lexical scope construction, so that we can continue doing all this stuff, you know. So probably like that. Now, what's the problem? And yeah, we also have to deal with the type things, because we don't have some kind of clear way to get it. I believe we have, where is the indices? Yeah, some kind of this thing happening. But the types table, we haven't defined it. The target type, first type. Probably types table is better. The module count, the module info, compiler, modified modules, blah blah blah. EagleFly function data func scope. We haven't defined this yet. I'm gonna do it just for now like this. And well, of course we don't need this. And now this is called
And we had to change all this stuff, but it's okay. We would do that. So now we have to look at in the info data. Now we have to do something like a little bit different. Okay, so I have an idea here. Yeah, this way probably it's gonna be some kind of a, imagine some kind of cache, like this kind of one or two or three caches where we have like these the construct lexical scope is the one in charge of creating some kind of data structure that's gonna have the whole data information for let's say for giving information for that specific scope or a set of scopes, whatever, so that we don't have to reconstruct it every time. It's gonna work some as a cache itself, so that I'm gonna stop here. I'm gonna say something like this: display line symbols. This was the first one that we defined, but probably we're gonna make something better. It's not sufficient. This is okay. It's not gonna have a problem. So it's gonna be something like this: lexical scope. It can even be, yeah, I mean, instead of having it here, we can just have it like as a cache. It can be something like lexical scope. So that instead of having this, it will be here, and then every time we have that, we have to pass the lexical scope and the local symbols. You know what I mean? And this is so that we have like this easy way to have this assume call block as we had before, but we have like the nice and convenient displaying stuff for the lexical scope as a cache. so that we can work with it right here. I think that's what we want. That's more like the thing we want. So yeah, so this is gonna be lexical scope. And probably, I don't know if we want something more. I think this way. So I'm gonna define all this as the next thing to do. So in that sense, I guess And the nice part about this is that probably we can create lexical scopes across different across different code segments, and I think that's really nice if we wanted to. Okay, so for now I will define just the, well, I will leave this like this, and what I want to do now is to say something as uh, 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 how does the file itself is gonna be inside memory, sorry, in disk. So we probably want I think I'm gonna keep it on memory,
you know, because probably, I mean, that's the thing that we've been like kind of looking at. I mean, even though having a file with the data itself being explicitly formatted, I think it's okay to have the data. I mean, we can take that into consideration, but for now we're not gonna construct that file. We just keep it for the PDB. The PDB parser is gonna construct the whole data memory layout so that we have all these data in memory as possible. And whenever we see that we need like this kind of virtual memory thing, we'll start like constructing all that stuff. But for now, I would say that I think that's the kind of more direct thing to do, so that we can play a little bit more easily on how that memory gets, how easily we can play with that memory from the parser to this thing, to the Lexer and to the all this stuff that has to happen so that we can display all this data. So we can say, oh, get the data, lex it, construct it, and everything else. Because this starts, if you think about it, this starts to kind of define a Lexer itself, which is kind of interesting. So yeah, I mean, I think we will take a look at that on the next stream, because the stream has ended. Let me see if we compile. Yeah, we do. So yeah, I think this is starting to look pretty much better and a little bit more into deep on how do we want to display this data, which is really, I mean, this is the most important thing, because if we don't have this, of course we cannot know what data and how the format of the data is going to be. So I think that would be good. The thing let me see. Okay, so it's gonna work as a set of pushes. Just let me just before finishing, I just want to say something here. Where is it? I mean, it doesn't matter because it's already commented, but where is the loader? Here's the loader. There you go. So we can play more in that sense, It's gonna be a direct call. We're gonna do it with that call. That is gonna be, and we have to and probably well, it has everything there, so we can just make it reasonable and get it. But let me, yeah, well, it doesn't matter. I mean, I just wanted to display that, hey, we're gonna play with that arena a lot. So yeah, I think that will be all. And please, if you have any questions about what we did today, feel free to ask them, and I'll be there to answer. You can post your questions on Twitch, Twitter, or YouTube. And yeah, so I think that's all for today, and I will see you all on the next stream.